Okay, so now talking about significant figures or sig figs. This is one of the fundamental differences between numbers in chemistry versus numbers in math. Okay, and again, it all has to do with the fact that numbers in chemistry correspond to measurements. So let's say that I was taking a measurement as to the length of my iPhone here, right? So I'm going to use this ruler. I'm going to look and see that the length of my iPhone corresponds to this right in here, right? So between 16 and 17. I'm going to sort of eyeball it and decide that this would be 16.4. In this case, my ruler is in centimeters, so 16.4 centimeters. Okay, this last digit here and the last digit in all of our measured numbers is what's called the uncertain digit, or sometimes called estimated, but right? This iPhone really could be 16.5 centimeters, could be 16.3 centimeters, somewhere in there. That last digit is the one that I'm not exactly super confident about. I know it's between 16 and 17, right? That's pretty obvious. But that last digit, I'm a little uncertain of. Okay. And that's a big thing about chemistry and numbers is when you're writing down a measurement, the digits that you include, they say something about the certainty of that measurement. So let's take two different pieces of glassware that gets used in the lab. One is a beaker. A beaker is a really inaccurate tool for measuring volume. It's great at holding volume. If you want to take something from one end of the classroom to the other, it's super convenient. But in terms of actually measuring volume and getting a good measurement out of it, it's not really great, right? So if I filled this beaker up to the line 150, when I recorded the volume of that liquid, I would record it as something like 150 milliliters of water. Okay. Now, what if I used a volumetric flask? A volumetric flask is this guy here. It's a very accurate piece of glassware for measuring volume, right? So what it is there's like a little notch on this long end of this tube here, and you fill it all the way up. And once you fill it up to the line, you stop, and that's like exactly 150 mils. So if I were to measure a volume in a volumetric piece of glassware, I would record my volume as 150.00 milliliters, right? So again, in the beaker, it's 150 milliliters. In the volumetric flask, it's 150.00 milliliters. Well, if you were a mathematician, you would say these are the same numbers, right? They are. They're both just 150, 150.00 and 150. They're the same number from like a mathematical standpoint. But from a scientist standpoint, from a chemist standpoint, one of these numbers represents a way more accurate measurement than the other, okay? Because in the beaker, I don't have that .00, right? So what I'm basically saying is I know that that measurement is somewhere between 160 milliliters and 140 milliliters. It's somewhere in there, right? That's my uncertain digit that I was talking about. Whereas with my volumetric flask, I'm saying it's somewhere between 150.01 and 149.99. Right? That's a much more narrow range for my volumetric flask than for my beaker. And that information was conveyed by the number of digits that I wrote. Okay, that's what significant figures is all about. We're going to spend this next two lectures talking about significant figures. It has everything to do with sort of your certainty in a measurement, and in particular in that last digit, because it could be a little more, it could be a little less. So however many digits I write corresponds to a more precise measurement. Okay, before we get, so first step that we're going to need to do when we're talking about significant figures is the ability to count significant figures given a particular number. Okay, so there are certain rules that we're going to apply for counting sig figs. That's going to be the big takeaway of this lecture. Do you know how to count sig figs? Okay, so again, there's going to be different rules. The first rule, rule number one, is, given a number, any digit that is not 0 is considered a significant digit. So right off the bat, just FYI, zeros are going to be the trickier ones here, okay? But any number that's not 0, we automatically know is significant. So let's take these measurements here. How many sig figs do I have in 18,911? Well, none of those are 0, so all 5 of those are significant figures, significant digits. 4.1, how many significant figures do I have? Significant figures and significant digits are synonymous. Well, none of them are 0, so there are 2 significant figures in that number. 58.63, again, none of those are 0, so this would correspond to 4 significant figures, right? 1, 2, 3, 4, all significant. If you have zeros located between non-zero digits, they are significant, right? So again, I told you zeros are going to be the tricky ones. If they're bookended by 2 numbers that are not 0, they're automatically significant. So in 101, this one's significant. This 0 is between 2 non-zero digits, so it's significant. And this last one's also significant. So this would have 3 significant figures. Likewise, in 5002.1, they are sandwiched. So this would be 1, 2, 3, 4, 5 sig figs. Okay. And 8.05, again, sandwiched between 2 non-zero digits. So this would correspond to 3 significant figures. Okay. Zeros that are to the left of the first non-zero digit are what I like to call leading zeros, are not significant. Okay, so given this measurement here of 0.11, I'm going to ignore the leading 0 and start counting 1, 2, right? So this measurement here would only have 2 significant figures. I don't count that leading 0. Likewise, for this measurement here, don't count, don't count, don't count, don't count, don't count. This only has 1 significant figure, right? Because all of those other zeros are leading zeros. Same over here. This one doesn't count. This one doesn't count, but I have 1, 2, 3. So this would have 3 significant figures. Okay. Trailing 0, so that covers leading zeros. Zeros to the right of the last non-zero number, or what I like to call trailing zeros, are only significant if the number contains a decimal point. Okay, so if the number has a decimal point, we'll count those trailing zeros as significant. If it doesn't, we're not going to count it. So we look at our first one, 9.10. This one's significant, this one's significant, and because I have a decimal in this number, this one is also significant. So this would be 3 sig figs. What about 0.1500? I'm not going to count this leading 0, because leading zeros never count, but I'm going to count this one, and then because these two fall in a number that have a decimal, they count as significant. So this would be 4 significant figures. All right, and our last one, again, not going to count any of the leading zeros, but I'm going to start counting these ones. This middle one is sandwiched between 2 non-zeros, so that's definitely significant. And then because this number contains a decimal, these trailing zeros are also significant. So this would have 5 significant figures. What about in 12,000? Well, this one's significant and this one's significant, but these trailing zeros are in a number that doesn't have a decimal. So these trailing zeros do not count, and I only have 2 sig figs in this number. Same with my other measurement is a little bit, kind of in the same boat. I have 1, 2, 3, but I'm not going to count this last one because there's no decimal in this number. If I wanted to represent 1,320 and have that last decimal be significant, I would write it as 1,320 and then a dot there. And all that dot would be doing is letting you know that that last zero is indeed significant, right? Because it's in a number with a decimal point. So this would have 4 sig figs. Okay, so notice the subtle difference between these two measurements here. I just included that decimal place in that bottom one to indicate that that trailing zero was significant. Okay, so that's how we count sig figs. Let's go about counting sig figs in each one of these measurements here. For A, I have 1, 2, 3 non-zero digits. That's an easy one. This one's 3 sig figs. In B, I have 1, 2, this one's sandwiched between 2 non-zeros, so that's definitely significant. 4, so that would be 4 sig figs in that measurement. In C, I'm going to ignore my leading zeros, but everything that comes after is significant. So this would be 3 sig figs. D, notice that D is in scientific notation. Scientific notation is actually really awesome for sig figs because just by virtue of how scientific notation is written, you know that everything after the decimal is going to be significant, right? Because I've got a decimal place in this number, and so these trailing zeros are indeed significant. So this number has 1, 2, 3, 4 sig figs. You only ever write down the significant digits when a number is in scientific notation. 50 milliliters. Well, this one's significant, but that trailing zero, I don't have a decimal in this number. So there is only 1 sig fig in this 50 mil measurement. How would I make it so that that last digit is significant? Right? If I put that decimal point there, all of a sudden that would become significant, but that's not there. All right, and then the last one, I'm not going to count my leading zero, but I am going to count 1, 2, 3, and because there's a decimal in that number, that fourth one counts as well. So this would have 4 sig figs. One last thing to, I guess not last thing, but one more thing to talk about when we're talking about sig figs is there are some numbers that you don't have to worry about sig figs for. Those are called exact numbers. Okay, so for example, anything that is a count is an exact number, right? So if I said 14 eggs or 3 cats, right? It's not like you could, are you maybe talking about 2.9 cats or 3.1 cats? No, you're talking about exactly 3 cats, right? 21 people, it's the same idea. Is it maybe 21.1 people or maybe 20.9 people? No, you're always talking about exactly 21 people, right? So anything that's a count, you're counting 1, 2, 3, those are exact numbers. And you don't, basically, they don't have significant figures. You don't have to worry about them. When we're going to talk next lecture about carrying sig figs, you don't have to worry about them when we're talking about carrying sig figs. They don't have, the concept of significant figures doesn't apply to these exact numbers. We're also going to see like conversion, some conversion factors are exact. What I mean by that is 1 inch is defined as 2.54 centimeters. That conversion is exact. There are not 3, you'd be tempted to say there are 3 sig figs in this number here. And going by our normal rules of counting, you're exactly right. There are, based on how that number is represented. But this definition is set in stone. An inch is defined as 2.54 centimeters. So an inch is never maybe 2.55 or maybe 2.53. This is what it means to be an inch, is to be 2.54 centimeters. So that conversion factor is exact, okay? And again, we'll see this when we start talking about conversions, but it means that we won't have to worry about sig figs when we use those numbers. All right, the last important thing about sig figs is rounding to a sig fig, okay? And this will make a little bit more sense when we start about like multiplying and dividing and adding and subtracting numbers. But the bottom line is, let's say that you were given a number like 102.731, and you were told that this 3 is actually the last significant digit. Then what you would want to do is round your answer to that sig fig, okay? In this case, if it's a number from 0 to 4, you round down. So that would be like this case. This would round to 102.73. If instead the original number was like 102.735, this would round up to 102.74. Okay, go back to how it was. But you'll round to a particular digit, and that's the last sig fig. Okay, what's important, and we won't do too many multi-step problems, but if it is a multi-step problem, you will never actually round until the very last step of your problem. And so we'll do some examples, but basically you want to carry all the digits that your calculator gives you. You can mark which one's significant, but you don't round until the very end. We'll see an example of that. Okay, but now here we're going to round each number to 3 significant figures. So what does that mean? What does that mean? I'm going to start counting from the left of my number, 3 significant figures. So here's 1, here's 2, here's 3. This is my last sig fig. So I'm going to round this number to that sig fig. And in this case, I would get 12,300. And importantly, notice that if I went back and applied my rules of counting sig figs, this number would indeed have 1, 2, 3 sig figs, but I wouldn't count those trailing zeros, right? So the whole idea is after you round, the number that you arrive at has 3 sig figs. Okay, so let's round this measurement here to 3 significant figures. Remember, I'm going to skip these zeros. They don't count as sig figs. But here we have 1, 2, and 3, so I'm rounding to that 9. You just look at the next door neighbor, that's a 4, so this would round down to just, I don't know how I got that. This would round down to 0.0129. Okay. If we go to our next one, 163,499, I'm again going to mark that third sig fig. This is what we're going to round to. And again, I'm only really looking at this next door neighbor. You don't first round this one to a 5 and then round. You only look at that next door neighbor, which would make this 163,000. 1, 2, 3. So I'm going to round to this 4. So this would be 1.35 because 6 rounds up. Okay, again, rounding to 3 sig figs is going to count from the left. 1, 2, 3. I'm rounding to this 10th place. So this would be 49.1. Again, sort of beating a dead horse here, but rounding to this third sig fig, this would be 591. Rounding to our third sig fig, it's a 3, so it rounds down to 49.3. And then this is a good example. We got 1, 2, 3. We're rounding to this digit here. Well, that would give me 3. Right, when I round it up. But importantly, I need my answer to have 3 sig figs, right? I'm rounding to 3 sig figs. That means my answer should have 3 sig figs. So I don't just write 3, I'm going to write 3.00. So that answer that I've given has 3 sig figs.